Go. Yeah, let's get our journals out then. Thank you, John. No, you're doing fine. And then today is our November 16th lesson. This is STAAR Review. And this is day 4 of 10. Thank you, Edgar, for already having your notes ready. Thank you, Ms. Aguilar, for already doing your notes. I appreciate it. Darwin over here, good to go. Thank you, Eric. Mr. Allen, we're in our notes right now, and we're going to start up here with 11:16 STAAR Review, day 4 of 10. In about 15 seconds, we're going to start. We're going to look at number 20 first. Look at number 20. All right, does anybody else need a calculator? Anybody need a calculator for today? All right, guys. Thank y'all for being so flexible and nimble today. I really appreciate that. Number 20 starts us off with an expression, x to the power of 3 multiplied by x to the power of negative 17. At first glance, this may look really complicated, but by the end of the problem, we're going to see that this is just an addition problem. That's it. It's just an addition problem. We're going to say equals x to the n. And they say, what is n? To the power of n. Because that's any number. N is number. Yep. Let's say, what is n? Like, what number could n be? We don't have to go straight to the solution here either. We're going to take a little bit of a field trip here. We're going to say that the first thing, example-wise, we're going to have over here is x plus x. All right, Mr. Edgar, if you have one x and you have another x, how many x's do you have? Muy bien. But something strange is about to happen when we change from addition to multiplication. Ms. Aguilar, what is x times x? We know that one is x plus x is 2x, right? So what is x times x? It's a challenge, right? It's a challenge. We know that it's going to be an x because 1 times 1 is 1. But look at each of these little x's also have an exponent of 1, right? So help me out, Miss Aguilar. If I have an exponent of 1, and then I have another exponent of 1, I have an exponent of 2. Very good. Perfect. Yeah. So this right here is going to turn into an addition problem. So we could have even something like x times x times x. What would that be? X to the power of what? X to the power of 3. Because these are all multiplication. But what if what's the difference here, Alan? What is x más x más x? 3x. Muy bien. So we're going to have x times x times x times x. All right, Javier, what do you think this one is? X times x times x times x. Perfect. That's exactly right. We have 1 plus 1 plus 1 plus 1 is x to the 4th. So John, what are we having to do? If they allow us to multiply our bases, what are we having to do with our exponents here? We're having to add them up. So if we have to do the same thing, we have to multiply x times x, what could we do with our exponents here? We can just add them up, right? So that's the only thing we need to do for this problem, is say we have x to the third times x to the negative 17. And use this pattern as our answer. What did you get when you did that, John? Negative 14. That's exactly right. So Eric, the final answer though is a little bit trickier. They asked you what is the value of n. So what would you have to answer here? Negative 14, that's right. All right, so Mr. Edgar, what if we had x squared times x to the power of 3? When we multiply these, Mr. Edgar, we have x to the power of what? What will be your final exponent here? No, we're multiplying x times x, right? Okay, and then what will my exponents have to be? I was trying to ask Edgar, but he's struggling on like if it's going to be multiply or add here.
Okay, este círculo güey está dividido en las dos x, eso lo multiplicas, imagínate que son números, es 1 por 1, eso va a ser, va a ser una x. Luego de arriba entonces pues lo sumas, va a ser 5 arriba de la x.
¿Entiendes más aquí? ¿Más aquí? 2 más 3. Sí, ¿qué es eso? 5, sí. Muy bien, muy bien. Alright, so Miss Jennifer, tenemos x elevado 4 por x elevado 6. ¿Qué es la respuesta aquí? ¿Qué es eso? Más, suma. Muy bien. To the power of 10. Very good. 4 más 6 igual 10. Just for this first few minutes, just to warm up, just to get the practice in. Perfect. Thank you for our key point today. That is a huge, massive key point that Miss Aguilar just gave us. That is something that needs to go in here. When we multiply x's, when we multiply the x's, what can we do? The what? The exponents. Good. We add the exponents. Fantastic. All right, guys, get that in your learning log. This is a huge, huge key point for today. Muy bien. That is very well said. And that's very much to Javier's point is what he was saying, is if you multiply x por x, then all of the elevados son suma. ¿A suma? Mm-hmm. I didn't. I didn't. No. One of the best things about, well, I know some verbs and things like that. But one of the best things about math is substitution. Substitution allows me to write computer programs. I've never taken computer programming class. It allows me to speak multiple languages. I've never learned. It's just because you take what you know to be true and put it into the whatever it is that you're saying. Now, a language that I do know from that's the only thing you know. Was ist mit dem aus? Yeah. Do this last one and then we'll take a break. We're going to look at number 21. Alright, guys. So we're going to say population in Houston. Population of 2nd Ward. Alright, this graph is going to be called the population of 2nd Ward. We don't have negative people and we don't have negative time. So we're going to make our graph an L shape. We're not going to have negative people. We're not going to have negative time. So we just need quadrant 1. Alright, so population. You're up and coming. You got this. It's not too bad. It's a little scary. It's not too bad. It's not too bad. I'm a little white, man. I'm a little gringo for this neighborhood, so. Alright, so we're talking about population. Alright, 200,000, 300,000, 500,000, 800,000. I made that up. Y 1 million. Okay. En X tenemos años después. Yes. They were just, there's too many numbers to write in there. All right. $600,000, 800. And then 1 million. There we go. Just a little bit. And then over here, we're going to put in 20 años después, 2015. 40 años después, 60 años después, 80 años después, 100. Okay. So este año aquí. Y este año aquí en 0. La pregunta dice range. So all we're going to do today is find the range of this function. Probably should have started with that one and not the exponent ones, but it's good to have that example in your head for today's lesson. All right, Mr. Eric. How many people do you think are in 2nd Ward? Right, okay, so 4 million in the metro Houston area, 6 million in the surrounding areas altogether. How many do you think are in just this neighborhood? I know. I really know. What? Ballpark, do you think it's 1 million? No. Do you think it's about half that? Do you think it's about less than that? What do you think?
Less than half. Okay, so less than half a million. That's not halfway between. That's about 250,000.
All right, guys, so let's say that the population in our neighborhood right now is 250,000. So, Mr. Edgar, come on over here to your graph of the y equals and go up to 25. Comienza su gráfico en 25. 250,000 personas. ¿Hmm?
That's too much. Oh, let's get around. All right, man. It's like, what is that?
Coming in looking like the Cholos today. All right, yo. Okay, so put your first point right here, por favor. Right there. And we're going to say at 2015, at year 2015, that was 2 years ago, we had about 250,000 people. Now, come on out here to 100 years from now, in 2115. About 100 years from now. We're going to be almost at 1 million if we keep growing like this. So make your graph curve this time. Exponential curve. I think everybody's starting to live longer. Science is going to help out. Like, we're starting to cure some cancers and things like that. I feel like we got a shot.
He's got a job.
Yeah, y'all trying to hold me up. I got to get out of here. All right, quick question. Mr. Javier, what is this thing right here, this symbol that I'm highlighting yellow, the one that's near my finger? What does this symbol mean? It means, does it mean it's going to stop or keep going? Is that what this arrow means? Forever and ever, right? Okay. Okay. Mr. John, is this your range or is this your range? Wait. Okay. So my range should be population? Okay, so for this question, for range, we're only going to be looking at this part of the graph. Okay, so this is range. Y la pregunta dice que es range por este gráfico. Okay, so esta función. So when they say what is range for this function? All right, Mr. Allen, what number do you start at on the y-axis? Comienza en ¿cuál número? 250,000. Muy bien. Okay, so put that one down. He just gave us this first answer. 250,000 people. John, one more time. What axis is range on? X or Y?
No, Y.
Perfect. So put your Y here. Now, do you notice this graph going to numbers bigger than 250,000 or to numbers smaller than 250,000? It's going bigger. So let's put bigger than. Now, did we actually start at 250,000? Is that an open or a closed out? This right here is open or closed. Cool. All right, so let's make it a closed sign. Okay?
So, of its closed X, no line. Of its open, no line.
Where? Oh. John all day today. God, this is dang. God. Yeah, can you put it in the door? Thanks, bud. All right, guys, let's take that first break in our class. Just kind of get our brains back to where they need to be. I'm going to put your minutes on the clock, and then when we come back together, we'll pick up where